Six Sigma Greenbelt, this is Unit 5. Now, if you remember, the second step of define, measure, analyze, improve, and control is measure. So what are we going to measure, right? So we got to do some process analysis. And this guy Amdo wrote a dictionary with all quality terms. He says a process is a set of interrelated resources and activities which transform inputs into outputs with the objective of adding value. We talked quite a bit about value added. But the bottom line is, if it's an important activity, document and control it, right? You know, the last step will be control, but you can't control it unless you got it documented. Now you got to model your process. What is your process? And you'll hear everybody say, yeah, I'm a visual learner. Yeah, that's true. We all are. Humans just do better with pictures than they do with writing. So flowcharts are process maps, basically. You just go and you follow a process through each different step. Another alternative is the written procedures or work instructions. Basically, you just document it. This is you just basically write down what's going to happen in the process. And then you have value stream maps. These things incorporate a bunch of information, not just pictures, but also information about what's happening during each process step. And I'm going to include some documentation on these, so I'm not going to spend much time on it. But they're all good ways of modeling the process, and you have to do this. So ultimately, what we want to do is, when we do the process, we want to get the inputs, what goes into that process, and what comes out. And is there a relationship between those two? And that's the whole goal of Six Sigma. And you can see this all the time. You see these models, these mathematical models and simulation in the computers. That's the kind of relationship we want, right? And then you want feedback from downstream metric to improve the upstream. So what you want is, what are your customers telling you? And we don't want just anecdotal. We want hard metrics, right? So we want to be able to measure our output somehow. What's critical to the customer? And we want to trace that back to our input. And I'll cover the SIPOC in the next slide. Okay, this is an example of the SIPOC suppliers. They're going to make tea, by the way. So the suppliers, you got the water company, you got the electric company, the supermarket. So those are the suppliers, but what do they bring to the process? What do they provide? Well, the water company gives us water. Electric company gives us electricity. Supermarket gives us the tea bags, and it's going to be British, so it's going to have bottles of milk. If you put sugar in your tea, you can add that in there too, probably. So what is the process? This is how you make tea in this very British way. You add water to the kettle, you boil it, you add tea bag to a cup, you add boiling water to the cup, you add the milk, remove the tea bag, and then you serve a cup of tea. I'm not going to say anything, but I always remove my tea bag before I add the milk. But, you know. So what comes out? Well, you got your cup of tea. You got a used tea bag, right? So who are the customers? Well, the garbage man's going to get this, and your friends or your wife or whatever. But that's the process. So you start with who supplies and who ultimately ends up with the product. I'm going to make a separate video on this one. But again, we're looking for that relationship between the inputs and the outputs. So we're going to start with a cause and effect matrix and a cause and effect fishbone matrix or Ishikawa diagram. Again, I'll make a video. But this is our first stab at trying to do a relationship between the inputs and the outputs. So we're going to collect some data. And there's two types of data. There's attribute data, and this is discrete. By that, we mean it can only be integers. So if I'm like talking about the color of the car, it can only be one color, blue, black, white, red, whatever, right? It can't be blue and a half, right? You see what I'm saying? So some examples, number of defects, how many people are absent, is it raining, is either raining or not, go, no-go data, pass, fail, that type of thing. Variable, on the other hand, could be any real number, right? So Say, well, how long is it? Well, it's 12 inches. No, let's go better. 12.2. No, let's keep going more. 12.32. And you can keep on going forever, splitting it, splitting it, splitting it, splitting it. Time is an example. How much does it weigh? Um, Basically, if you can split it more than one way, it can go on. That's variable data. And locational data is where's this happening. Great example of this is we had a safety uh, director wanted to know how he could cut down accidents. So he did is he had a big picture of the factory blueprint. He marked where all the accidents were happening. It turned out that most of them were happening in the bathroom. It was people would get the floor wet, slip on it, and hurt their back, right? That's why you use locational data. Where is it? Okay, here we go. We got some examples, and I'll let you read this to yourself. But basically, if you look at all the continuous data, right? The weight of the car, the mileage on the car. This is all from the car, by the way. How much gas in the tank, the pressure on the spare tire. Those things can be split. Notice the decimal point in it, right? You got attribute data. Well, I got a two-door car. It's a white car. There are 3 chips in my windshield. You can't have half a chip in your windshield. It's either there or not. That's the difference between continuous and the attribute data. Okay, so we're going to collect this data, right? If you have data already, don't ignore it. I just did a live class, and man, these guys had so much data. They knew how long each process was, the bill of materials, the defects, but they didn't do anything. They collected and didn't do anything. If you got that, use it, right? But if you don't, you're going to have to collect it. So what is the problem you're trying to solve, right? What are you going to measure? What characteristics? You want numbers, not anecdotal. Although I will talk a little bit about Likert in another video. What's your measurement technique? And we'll talk about measurement system analysis. How do you going to collect that data? Who collects the data? How are you going to sample it if you're going to sample? And what happens with the data? Right? Don't collect data just to collect data. You got to have a reason for collecting it too. So you got to summarize the data, collect and summarize it. We used to have a little check sheet that the operators, they'd have to go down and just basically, what is the temperature of the coolant? What is the, how old is the tool? Things like that. And they just made a check sheet all the way down. Another way, checklist, we're all familiar with that. I'll provide a link to the checklist maker. And also, there's a great iPod or podcast I'm going to share with you. And you computerize it, right? You got to be careful. Bias is where it leans one way. It's not centered. It's not calibrated. A lot of people like to fudge it a bit. They know what you want. You got to be careful with that. And there's a way of coding it. If you got like 7 or 8 different digits on there, you can code it so you don't have to collect the last 2 digits if it doesn't vary so much. But you want to collect that data. So we got to worry about data accuracy and integrity. Avoid emotional bias. I used to make a bet that we'd go out on the floor and I'd have a part and then maybe calipers or whatever. And I always said, what's the first question the guy's going to ask? Well, what's it supposed to be? And he'd sit there. If he didn't quite get it, he'd squeeze a little bit harder or back off just a little bit to get what it's supposed to be. You want to avoid that, right? Avoid round-off errors, right? Sequence, we're going to talk about time. You can see trends this way. And you want to capture the changes as soon as possible. SPC, we're getting towards the SPC here, statistical process control. Apply the stats. In other words, we're going to analyze it. We're going to filter the data, make sure we don't have any bogus readings, no outliers. Don't trust your hunch. It's got to be real. And I've got a little video on Greek science that will explain. It's basically this thing. And make sure you got the time, machine, auditor, operator, gauge, lab, material, target, etc. What you see here is we're looking for differences between those, right? Why can one operator make a good part? Another operator couldn't make one to save his life. There are different types of sampling. By definition, random means that every member of a population has an equal chance of being pulled and studied for the sample, right? So it's very random. Sequential. If you got a continuous process, you just basically take readings every so often and just plot them, right? And stratified, if you got like two suppliers, parts made on 2 different days, what you're going to do is see if there's a difference between those two different lots. Again, we're all visual people, right? So you want to have some graphical methods. I'm not going to spend too much time on this. For homework, go ahead and do an internet search and look these things up. Box and whisker plots. I don't see too many of these, but Minitab has this, and there's some macros you can get at Excel. Stem and leaf plots. Again, this one is in old times before we had computers. These were kind of helpful. Scatter diagram. This is a huge one, and I'll make a separate video on this one, how to do one in Excel. Pattern and trend analysis. Again, we're talking about statistical process control type thing here, right? Do we see something going on? And we can do it not just in SPC. We can also do this if we look at different locations. Say we want a thickness of a metal plate. Are we finding the variations in a certain spot on that plate? Or is it where does it occur? Histogram. This is the beginning of building up a normal. See what it looks like. See if it's bimodal, single modal, whatever you might have. But basically, just plot the information and make a chart. And normal probability plots. This is the old Gaussian curve, right? This is what we're hoping for. And we'll get into that a little bit more as we go into statistical methods. Again, I wanted to focus a little bit on this normal plot or normal curve, bell curve, Gauss curve. What you see then is we got, say I'm looking at apples at a store. Well, I got some kind of average weight of an apple, right? In this case, it's 75 grams, let's say. And most of the apples in the store are right around that 75 grams, right? But pretty much, half of them are going to be bigger than that. Half of them are going to be less weight than that. The further away I get from that average, the less and less I'm going to find, right? So I'm not going to find a whole bunch of apples at 45 grams, and not many at 105 grams. But I'll find quite a few between 70 and 80 grams, right? That's the way normal plots work. And this is the way nature generally does it. And here are the links.